This is part 2 of lecture 4.2, isotopes and ions. The first part was taking a look at isotopes. This is going to be taking a look at what are called ions. So I want to define first what ions are, and then we can take a look at some examples. So ions. With ions, your protons and your neutrons do not change. If we change the protons, we have a new element. If we change the neutrons, we change the mass, and we have an isotope. So these are not changing. So what's left over for our subatomic particles that could be changing? That is going to be the electrons. So the protons and neutrons do not change. However, the electrons do change in an ion. So we're going to take a look at two different types of ions. And we're going to start off with sodium. Sodium, the symbol for sodium is Na. And sodium is going to lose one of its electrons. And so it's going to become Na. Well, if it loses an electron, it's losing a negative charge. If you're losing a negative, what do you become? You become positive. So let's take a look at sodium. If you look at your periodic table, look at your periodic table right now for element number 11. We're going to take a look at the protons, the neutrons, and the electrons. So we're going to take a little chart here. Here's the protons, here's the neutrons, and here's the electrons. Regular sodium is element number 11, so it's 11 here. And the mass is 22.990. That rounds to 23, which means this plus this, which is the mass, has to equal 23. How many number of neutrons must it have? 11 plus what equals 23? 12. Now, this sodium is not charged like this over here. It's neutral, meaning the number of protons has to be the same as the electrons. This is going to be 11. But now we've lost an electron. Okay, what's happened here? We've lost one. It previously had 11. If it lost an electron, how many does it have now? It has 10. Well, remember, the protons and the neutrons do not change, so there's still 12 neutrons. There's still 11 protons. Let's take a look at the charges, though. Neutrons don't have any charge. Again, the charge of protons is positive. The charge of electrons is negative. Now I have 11 positives and 10 negatives. If I add 11 positives and 10 negatives together, that charge is going to be +1, which is why there's a plus up here. However, in chemistry, we don't write the symbol for 1. It's like H2O. We don't say it's H2O1, we just say it's H2O. So there's invisible ones right there, just like in mathematics. If you have 2x plus x, the second x is considered to be 1x. 2x plus 1x equals 3x. So it's the same with chemistry. We don't really write those, the ones. Let's take a look at another one, and it's going to be chlorine. Chlorine is going to gain an electron. So if you're gaining an electron, you're gaining the extra negative charge. What's the chlorine going to become? What's the charge going to be? Negative. Take a look at your periodic table, and you'll see chlorine is element number 17. The mass of chlorine is 35.453. That rounds to 35. This plus the neutron is the mass of 35. So 17 plus what will equal 35? And that's going to be 18. That gives the atom its mass. How many electrons must I have? Well, remember, we're not changing them. We're just starting with the same number of protons and electrons. So it's going to be 17 because chlorine is neutral. So my protons has to equal my electrons. But chlorine is going to gain an electron. So the 17 is going to become 18. Now remember, the protons and the neutrons do not change. So my protons is going to be 17. My neutrons is going to be 18. But now I have 17 protons, and I have 18 electrons. If I had 17 positives and 18 negatives, what's the charge going to be? It's going to be a -1, which is why we put the negative up there. And what happens is now sodium has the positive charge, chlorine has a negative charge, and they are now going to be like magnets. They're going to be electrically attracted toward each other, and they will create Na plus and Cl minus, or NaCl. They create the compound called sodium chloride, and sodium chloride is commonly called table salt. So that was a look at isotopes and ions. Isotopes can change their neutrons. Ions is when the electrons change.